Welcome to our Wizzy tutorial on simple LED circuits. Today, we will learn about LED, current limiting resistor, breadboards, and also create some fun LED projects using Arduino and ArduBlock. Let us start with LED and the current limiting resistors. LEDs are like little light bulbs that need the right amount of current to shine brightly without burning out. That is where current limiting resistor comes in. Current limiting resistor is used to regulate the flow of current passing through the LED, protecting it from getting damaged or burning out. Next, let us talk about breadboards. A breadboard is a handy tool for prototyping circuits without soldering. It has rows and columns of holes where you can insert components and connect them using jumper wires. To use a breadboard, simply insert your LED and resistor into separate rows, making sure they are connected to the right pins. Then, use jumper wires to connect the components to the Arduino board. Now, let us build some fun projects. First, we will create a simple LED blinking circuit. Then, we will make the LED fade in and fade out like a housebit using ArduBlock. With ArduBlock, you can easily program your Arduino board by dragging and dropping blocks. It's a great way to learn about coding without writing lines of code. The first thing is to arrange our LED circuit on breadboard, after which we can then program the circuit using ArduBlock. Now that we are done with the arrangement of our circuits, let us now program our circuit using ArduBlock. Starting with the blinking LED circuit, we are going to program the LED to blink every 1 second. Here, the ArduBlock software is already opened, and let us start by opening the text code panel. This way, we can see the actual code that is being generated from our block arrangement. Let us continue by clicking on Structure. Here, we are going to pick and drag the setup and loop block. We shall then move to the input and output section and pick the digital output block. This block will be placed inside the loop section of our structure because we want our code to keep looping over and running continuously without stopping. Here, the number 1 means the LED will be on, and changing the number to 0 will make the LED goes off. We then go to the time section so that we can use the delay block that will let our LED stays on for some time before going off. Here, the 1000 means 1 second, so we are going to leave the number unchanged. Then we go to the input output section again and pick the digital output block. But this time around, our value will be changed to 0, which means the LED will be off. We can then duplicate the delay block by right-clicking on it and selecting the duplicate option. This way, we can easily guess the block we want without having to go back to the overall block section. Let us now change our pin number to 9 because pin 9 is used in our circuit arrangement and not pin 13. Right now, that is all that is needed to blink our LED every 1 second. You can now upload the code and see the results. Let us delete the old block here so we can start programming the LED to fade in and fade out. Then we go to the cycle section and pick the incremental for block. This block can let us execute a certain block of code repeatedly for a specified number of times. Then we go to the input output section again, but this time around we are going to pick the analog output block. We are now going to change the pin number to 9 since our circuit is using pin 9 on the Arduino board. Then we go to the math section and pick the referencing block. This block can be used to set the analog value for the LED on pin 9. Once again, we go to the time section to pick the delay block. This is needed to prevent our LED from blinking too fast. We are going to change the delay value to 10 because we don't want the blinking to be too slow either. Go to circle again, and this time around we are going for the decremental 4 block. Before we proceed, let us quickly change the final analog value to 255 for the incremental 4 block, and also change the starting value of the decremental 4 block to 255. We can then duplicate and use the analog output block. Then change the arithmetic sign here to minus because we are now trying to reduce the analog output signal. This will make the LED brightness decreases, and then we can add some delay again. You can now upload this code and see the results. And there you have it. With just a few components and add block, you can create all sorts of LED projects. Have fun experimenting and exploring the world of electronics. Thank you for watching and happy practice. Stay tuned as we continue our lesson in the upcoming videos on coding and robotics. Thank you.